Hello, students. Now, today we can solve questions from the chapter complex numbers, which was asked in 2022 Keam examination last year. Okay, 8 questions were asked. Let us see how we can solve these questions. The first question, you have to find out the principal argument of the complex number set equal to 8 plus 4i divided by 1 plus 3i. So principal argument must always lie in between minus pi and pi. Okay, here we have to express the given complex number in the standard form. So Z is equal to 8 plus 4i. We simplify this. 1 plus 3i. Numerator, we can take 4 as a common factor. 4 into 2 plus 4i. Sorry. Here it is 2. 2 plus I divided by 1 plus 3i. You know the method, multiplying numerator and denominator by the conjugate of the denominator. Now, of course, denominator is 1 squared plus 3 squared. Numerator, when you multiply, you will be getting 2 minus 6i plus I. Now you are getting minus 3i squared, which is nothing but plus 3. Again, this is equal to 4 into 5 minus 5i divided by 10. So on simplification, you will be getting 2 into 1 minus I. Okay. What is the argument of Z? The formula is tan inverse y by x. What is y here? Minus 1. What is Z? Sorry, what is x here? 1. So tan inverse minus 1. What is tan inverse minus 1? It's minus pi by 4. So we got the answer. Minus pi by 4 is appearing in option B. Okay. Let's go to the next question. The minimum value of mod Z1 plus mod Z plus 1 plus mod Z minus 2. So we are using the inequality. Mod Z1 minus is Z2 less than or is equal to mod Z1 plus mod Z2. So this inequality we are using for solving this question. I am replacing Z1 by Z plus 1. So Z plus 1 minus, in the place of Z2, I am writing Z minus 2. Z minus 2. Okay. And on RHS, mod Z plus 1 plus mod Z plus 2. Okay. On LHS, we have got 3 less than or is equal to mod Z1, mod Z plus 1 plus mod Z plus 2. Okay. Now, which implies mod Z plus 1 plus mod Z plus 2 greater than or equal to 3. That is the minimum value of mod Z1 plus mod Z plus 2 is 3. Value is 3 or greater than. Therefore, minimum value of mod Z plus 1 plus mod Z plus 2 is equal to. So answer is option C. It's a very good question. Z equal to 3 plus I into 7 minus I the whole square, the whole divided by 3 minus. You have to find modulus it. We need not have to simplify this. You can use properties mod Z1, Z2 equal to mod Z1 into mod Z2. Mod Z1 by Z2 equal to mod Z1 by mod Z2, and mod Z raised to n is equal to mod Z the whole raised to. So here, now when you simplify by using these properties, we are getting modulus 3 plus I into modulus 7 minus I, 7 minus I square. Okay. 7 minus I square divided by modulus 3 minus. Modulus 3 plus I is root of 3 squared and 9 plus 1. Modulus 7 minus I squared is root of 7 squared 49 plus 1 the whole square. And in the denominator, again, modulus 3 minus I is root of 3 squared, that is 9 plus 1. So root of 9 plus 1, that is root 10 is getting cancelled. So answer is 50. So we are using the property and we are evaluating it. Answer is option C. Now the fourth question. You have to evaluate the given expression. Let us assume that the given expression is Z. Numerator we have got 5I, and denominator 1 minus I into 2 minus I into 3 minus I, the whole raised to 50. Okay. So the usual method. We multiply numerator and denominator by the conjugates of the denominator. So in the numerator, we are having 5I into the conjugate of 1 minus I is 1 plus I. Conjugate of 2 minus I is 2 plus I. Conjugate of 3 minus I is 3 plus I. And in the denominator, when you multiply with the conjugate, we are using the formula x plus iy into x minus iy is x squared plus y squared. So the first factor will be 1 plus 1. Second factor, 4 plus 1. Third factor, 9 plus 1. Now, numerator, we have to multiply and simplify. 5I into, you multiply the first two. 1 into 2, 2. Then 2I plus I, 3I. Then you are having I squared. I squared is minus 1 into 3 plus I. Denominator 2 into 5 into 10. The whole raised to 50. So it is equal to, again we are simplifying, numerator 5I into 2 minus 1, 1 plus 3I into 3 plus I. Divided by 100. 4 raised to 50. Numerator again you simplify. 50I into 1 plus 3I into 3 plus I. You are getting 3 plus I. Now 3 into 3I plus 9I. 3I into I, you will be getting minus 3. divided by 100 whole raised to 50. It is equal to numerator 50i into 3 and minus 3 is getting cancelled. You are getting 10i. Denominator 100 whole raised to 50. So when you simplify, you will be getting, so 50 by 100, 1 by 2. Okay. It's not 50, it is 5, sorry. So here it is 5. So you have got 50 by 100 is 1 by 2. And I squared is minus 1. So ultimately you are getting minus 1 by 2 raised to 50, which is nothing but 1 by 2 raised to 2. So answer for this question is 1 by 2 raised to 50. That is appearing as option B. Now, fifth question. This is rather easy. It is given that z raised to 4 is equal to 7 minus 5y. You have to evaluate imaginary part of z bar raised to 4. Okay. Now, z bar 4 raised to 4 is same as z raised to 4 whole bar, which is equal to 7 plus 5y. That is the conjugate of z ratio. Therefore, imaginary part of z bar raised to 4 will be imaginary part of 7 plus 5i, which is equal to 5. So it is an easy question. Answer is option. Okay. Now, we have to find out the modulus of the given complex number. For that, 1 plus I divided by 1 minus I. It is a result. What is it? It is equal to I. And what about 1 minus I divided by 1 plus I? It is the reciprocal of I. That's 1 by I. And 1 by I is nothing but minus I. Okay. Now we are using these results for solving this question. So you are being asked to evaluate 1 plus I divided by 1 minus I whole raised to 75 minus 1 minus I divided by 1 plus I whole raised to 75. Let call this as Z. Z is equal. Okay. Now I am simplifying this. 1 plus I by 1 minus I is I. It is I raised to 75 minus I raised to 75. So this is nothing but 2 into I raised to 75. You have to find out the modulus of this complex number. Therefore, mod Z is equal to modulus 2 into modulus I raised to 75. Now, modulus 2 is 2 only, and modulus I raised to 75 is 1. Because modulus I is 1. So answer for that question is 2. So easy question, but you have to use these properties of these results. Now let us go to next question. It's quite common. Similar questions was there in your, exercise in your board examination theory book. Now, it is given mod Z2 equal to 1. When you square, then also it is equal to 1. And mod Z2 square by property, it is Z2 into Z2 bar is equal to 1. And you are being asked to evaluate modulus 1 minus Z1 bar Z2 divided by Z1 minus Z2. So I am replacing 1 by Z2 Z2 bar. So the numerator, in the place of 1, I am writing Z2 Z2 bar minus Z1 bar Z2 divided by Z1 minus Z2. In the numerator, what is common? Z2 is a common factor, so it is Z2 bar minus Z1 bar by Z1 minus Z2. Now, by using property of complex numbers, we can separate this. So in the numerator, we are getting mod Z2 into mod Z2 bar minus Z1 bar divided by modulus Z1 minus Z2. Now, modulus Z2 bar minus Z1 bar equal to modulus Z2 minus Z1 the whole bar property. Or again, this you can write as modulus Z1 minus Z2 the whole bar, which is same as modulus Z1 minus Z2. These are properties of modulus of complex numbers. So by using this property, you know, it is given mod Z2 is equal to 1. So the numerator 1 into, in the place of mod Z2 bar minus Z1 bar, you can write mod Z1 minus Z2. Denominator also you got mod Z1 minus Z2. So they are getting cancelled. So answer for this question is 1. Okay. So this is answer for this 7th question. And the last question, answer is option E here. Question number 8. Now here, 3 complex numbers are given, and given that they are vertices of an isosceles triangle, which is right angle, like isosceles right angle triangle, that is what is given. Now, these complex numbers in Argand diagram, they are representing points. So let us see what are the points. -1 plus 7i. Let this be the point a minus 1 comma 7. X coordinate is -1, y coordinate is 7. Now -1 plus xi. Let's call this point as b. -1 comma x. And the third one, 3 plus 3i. Let's call this as vertex c. The coordinates are 3, comma. It's a right angle triangle, right angled at B. So let us draw the triangle. A right angle at B. Let's call this vertex as A, let this be C. So the coordinates of A are -1, 7. B are -1 x. C are 3, comma. When you observe the coordinates of A and B, the x coordinates are equal. If for 2 points, if x coordinates are equal, that line is parallel to y axis. AB is parallel to y axis. Why? Because the x coordinates of those 2 points are same. Therefore, BC will be parallel to x axis, because it is a right angled triangle. Right angled at B. Now, what about slope of BC? Is equal to 0 because the slope of x-axis is equal to 0. We know how to find out the slope. Y2 minus y1. So 3 minus x divided by x2 minus x1. 3 plus 1. 3 minus minus 1 is equal to 0. Definitely x is equal to 3. So by the help of coordinate geometry, we can solve this question very easily. So answer for that question is option B. Okay. Now, in the next class, we can solve the questions asked in the year 2021. Okay, from the chapter complex numbers. Okay, see you in the next class. Thank you.